virtual science lesson from A Time for Science is all about electricity and magnetism. But before we start to explore those concepts, I have a little bit of a magic trick for you. I'm going to make this tinsel float above this piece of PVC. Are you ready? Oh, that didn't work. Oh, I know I forgot the magic words, right? What are the magic words? Alakazam. That still didn't work. I just don't get it, guys. I'm scratching my head trying to figure it out. Why won't my trick work? Oh, there we go. Is that magic? Or is it science? We're going to explore that a little bit further throughout the rest of our lesson on electricity and magnetism. I bet you scientists at home probably know exactly what I'm using in order to make this float. I'm generating a lot of friction here, picking up a charge with my PVC, giving the same charge there to my tinsel. And when two objects that have the same charge come close together, they repel, which causes the tinsel to float through the air. Now, I'm sure you've all experienced static electricity, right? Have any of you ever walked across the carpet wearing socks and then touched a doorknob and gotten a shock? What about, have you ever been jumping on a trampoline and then you got off and you shocked your brother or sister? Did you do it on purpose? Well, if you did, shame on you. But I'll forgive you today because that lets me know that number one, you know what static electricity is, and number two, you know how to use it. Did you know we use static electricity in everyday technologies? How many of you like seeing a shiny, newly painted car? Well, did you know that they use static electricity to make sure that paint spreads evenly across the surface of the car? They give a charge to the end of the nozzle that they're using to apply the paint. And then they make sure that the car has the opposite charge. And that allows the paint to be attracted to the car and to make sure that it spreads evenly across the surface. Every time you use a photocopier, static electricity is going on behind the scenes. I'm going to tell you exactly how a photocopier works right now, so listen up. When a photocopier started, a high voltage wire distributes positive charge even across the surface of the bell to drum, and the tip of light moves across the surface of the paper to be copied. And then the white light reflects the button in the back of the drum bell. Reflected light strikes positively neutralizing it. The dark areas in the paper and text picture like strikes positively photocontamination on the metal, neutralizing. Dark areas of the paper and text picture do not spread lightly, neutralizes like a shadow. Negatively oppositely charged paper nose toner spread across the drum bell. The negatively charged particles are attracted to the positive charge region of the drum bell. A blank sheet of paper is passed charge to wire making positive and passed across the drum bell. The positively charged paper attracts toner off the drum bell. Paper goes to the teeth, pass through, copy, fuse to the paper. Copy that. Okay, well, maybe you didn't hear every little bit of what I was saying, but that's okay, because the point of today is not that you're able to understand exactly how a photocopier works. The point of today is that you understand all of these scientific concepts are going on behind the scenes in everyday technologies. And you all are going to be the ones who get to develop new and better technologies to make my life easier using these same scientific concepts, right? I hope so. I'm counting on you. Now, before we move forward, I have another magic trick I'd like to share with you. Today, I'm going to make this car move without even touching it, just by using my magic wand. Ooh, look at that. It's magic, right? I know it's because I'm a magician. Wait a minute. You don't think it's magic? But I'm making it move without even touching it. What would you say is happening if this is not magic? If you said I was using magnets to make the car move, you were absolutely right. Now, all magnets have poles. Every magnet has a north pole and a south pole. When we take the south pole of my wand, see it's labeled with an S, and put it near the south pole of the car, they repel, which sends the car moving forward. If I take the north pole of my wand and put it near the north pole of the car, they repel, which sends it moving forward. Let's see what happens if I take the south pole of my wand and put it near the north pole of the car. They are attracted to one another. So similar charges repel and opposite charges are attracted to one another. That is just a little bit about the force of magnetism. Now, that was just a little bit about magnetism, and we've discussed static electricity. Now we're going to move on to talk about electromagnetism. Electromagnetism is one of the four fundamental forces that holds together all the matter in our universe through the push and pull of electrical charges. Now, how many of you at home think electricity and magnetism are related? That they depend on each other? Together, all the matter in our universe through the push and pull of electrical charges. Now, how many of you at home think electricity and magnetism are related? That they depend on each other? That they are connected in some way? How many of you think they're not related? And how many of you don't know if electricity and magnetism are related? It's okay to admit if you don't know something, otherwise, how are we ever going to learn? I'm going to prove to you today that electricity and magnetism are related by building a very simple generator. Now, to build a Lorentz force generator, all you need is a simple battery, some pretty powerful magnets, and a conductor. Now, a conductor is anything that allows electrons to flow freely through it. We're going to use copper wire as a conductor today. Copper is an excellent conductor of electricity. Now, let's see what happens when I attach the copper wire to the battery. What's happening there? That's right, the copper wire is spinning very quickly. Is it magic? No, it's not magic. Magnetism. What's happening is the electrons stored in the battery are flowing through that copper wire, which creates a magnetic field. That magnetic field is interfering with the magnetic field created by the magnets below. Anytime there's a disruption in a magnetic field, electricity is created. Likewise, if there's a disruption in an electrical field, then a magnetic field is created. So electricity creates magnetism, and magnetism generates electricity. Now, that copper wire is still moving. When I touch it and I hold the battery, I realize that it's hot to the touch, especially compared to the battery that was not connected to our generator. That is actually just energy in the form of heat. Now, heat is just one of the many forms we're going to witness energy take during this demonstration today. So we know that we can generate electricity just by causing a disruption in a magnetic field. Now we're going to see if we can move an entire battery by using that same concept of electromagnetism. So to set this up, I still need a source of power, in this case a battery. I need some pretty powerful magnets, and my copper wire is in the form of a coil instead of a rectangle. Let's watch what happens when we put the battery in our conductor. Wow, it just pulls that battery right through. Let's see what happens if I put it in backwards. No matter how hard I push, the battery is repelled, being sent out. I wonder how that happens. This is also an example of electromagnetism. The electrons stored in the battery are flowing through that copper wire, creating a magnetic field. That magnetic field is interacting with the magnets, either pushing or pulling them through, depending on the orientation of the battery. So now I hope you all understand that electricity and magnetism are related. We can generate electricity simply by causing a disruption in a magnetic field. Now we've explored a little bit of the power of magnetism, static electricity, and we dove into the idea of electromagnetism. Now we're going to talk about electricity. Electricity is all about charges, kind of like that North Pole and South Pole when we were discussing magnetism. But it's not a North Pole and South Pole when we discuss electricity. There are positive charges and negative charges. Two positive charges repel, and a positive and a negative charge are attracted to each other. This is a Van de Graaff generator. It collects electrons using a fast-moving belt until enough of them build up on the dome to create a Each shock from the Van de Graaff generator exceeds 100,000 volts. Do you hear that sound? It's energy in the form of sound. Do you see that shock of light? It's actually energy in the form of light. Does anyone think that I should touch this Van de Graaff generator? Now I've put Elsa on the Van de Graaff generator, and she's having a pretty bad hair day. We know that she's picked up a negative charge because I told you that the Van de Graaff generator collects electrons, which have a negative charge. Now my wand has a slightly positive charge, and we can watch as Elsa's hair is attracted to my wand when I get close to that electrical field. Now humans also have a slightly positive charge in general, so I can affect Elsa's hair just by interfering with the electrical field around her hair. See how her hair is attracted to my positively charged hand. Now when I turn off the generator, electrons are still giving Elsa a negative charge. I can still affect her hair, maybe help her out with her bad hair day. Now we know that when two objects have the same charge and they come close together, they repel. So I wonder what will happen if we put these Tide tins directly on top of our Van de Graaff generator. Let's give it a whirl. They repel! The Van de Graaff generator gives each pi tin a negative charge, and because the pi tins are so close together, they repel, sending it flying through the air, defying the force of gravity, if only just for a moment. So those of you that said you wanted me to touch the Van de Graaff generator must not care too much about my health, but I like you guys, so I'll give it a shot. I'm going to put both hands on the generator, closing the circuit. We're going to turn the generator on and see what happens. Now those electrons travel up my arms, up my neck, and on top of my head, giving my hair what kind of a charge? A negative charge, right, because electrons have a negative charge. Because each piece of my hair has a negative charge, each piece is repelling away from the other, causing it to stand. So another way we can prove that humans can be conductors of electricity is by putting the pi tins on my head. Earlier we saw them fly off of the generator. Let's see what happens if we turn on the generator while the pi tins are on top of my head. They repel, sending them flying through the air. So we know that I have conducted the electrons from the Van de Graaff generator up to my head to the pi tins, giving them each a negative charge. Because they all had a negative charge, they repelled, sending them flying through the air. What did everyone think? Was that a good magic show? Wait a minute. Was it magic or was it science? Yes, it was all science. All jokes aside, there's no magic involved. It's just a matter of understanding the laws of physics that govern everything in our universe. Today we saw how magnets interact with things made of iron and other conductors, and we were able to make the car move just by using the force of magnetism. We were also able to observe how electrically charged objects can create a push and pull just by interfering with the electrical field around Elsa's hair, or when the pi tins went flying. We saw a little bit about static electricity, and we witnessed generating electricity just by causing a disruption in a magnetic field, or what we call electromagnetism. While you may not have all of these materials at home, certainly not a Graaff generator, you may have some of the materials you need to conduct these experiments, like simple piece of PVC pipe, maybe some tinsel from your holiday decorations. A balloon is another great way that you can conduct a static electricity experiment. Blow it up, rub it on your head, and see if you can generate some static electricity there. Even if you can't conduct any experiments at home, I encourage you to shock your parents with all that you learned during this video today. We hope that you had a good time with our magic show, and we hope to see you again next week for another science video.